In GIS and remote sensing, there is an important ethical difference between making data accurate and making data visible. Data correction, such as geometric correction, radiometric calibration, and atmospheric correction, aim to improve the physical reliability of satellite measurements. These processes are grounded in sensor physics and environmental modeling, and they ensure that pixel values represent real-world surface conditions as consistently as possible. Correct data can be compared across time, space, and sensors, forming a trustworthy foundation for analysis and decision-making. Image enhancement, by contrast, is designed for human interpretation. Techniques such as contrast stretching, gamma correction, and histogram equalization redistribute pixel values to make patterns easier to see. These methods do not change the underlying measurements, but they can strongly influence how scenes appear. This distinction matters because visual choices are never neutral. As cartographic scholars have long shown, changes in color, contrast, and symbolization shape how viewers interpret meaning, importance, and risk in a map or image. In remote sensing, enhanced imagery can appear more detailed, more dramatic, or more definitive than data supports, especially to non-expert audiences. The ethical risk arises when enhanced images are mistaken for more accurate data. A visually striking image may appear better or clearer, even though it's no more scientifically valid than the original. When an image circulates without explanation, they can be read as photographs or objective truth rather than interpretations shaped by technical and aesthetic choices. This risk is not distributed evenly. Research in critical GIS shows that visualization and data practices often intersect with existing power structures, particularly in communities already subject to surveillance, misinterpretation, or regulatory scrutiny. Enhanced imagery has been used to justify enforcement actions, environmental claims, or land use decisions in indigenous, rural, or low-income communities, even when uncertainty, context, or local knowledge is missing. For example, satellite imagery of a rural or indigenous community near a watershed may be enhanced to highlight land cover differences for environmental review. After contrast stretching or color enhancement, certain parcels may appear as bright, irregular patches that suggest disturbance or illegal clearing. To outside regulators, the image can imply environmental harm and trigger inspections, fines, or public scrutiny. Yet on the ground, those same areas may reflect seasonal agriculture, traditional land stewardship practices, or recovery from earlier state-approved extraction. The data itself has not changed, but the enhancement has altered how the landscape is interpreted. When such images are presented without context or community input, visual authority replaces local knowledge, and what appears to be neutral analysis becomes a source of regulatory harm. Analysts, therefore, have a responsibility not only to understand enhancement techniques, but also to communicate clearly what enhancement does and does not mean. Enhancement affects interpretation, not physical truth. Without that clarity, visual outputs can unintentionally reinforce narratives of neglect, disorder, or violation, especially in places already burdened by historical inequity. Responsible GIS practice requires being explicit about this distinction. When images are shared with decision makers or the public, analysts must clarify whether changes reflect improved data accuracy or improved visualization. Ethical practice also means asking who is likely to be affected by how an image is read and what assumptions viewers may bring with them. Accuracy is a scientific goal. Appearance is a communicative choice. Confusing the two can mislead interpretation, shape policy in harmful ways, and erode trust in communities whose lives and lands are being represented from a distance.